Yeah, is it all right, everyone? Am I audible?
Yes, sir.
Yes, sir.
Good. So here, this is the matrix A, beta. This is the matrix A. 1, 2, 3, 5 I have given, and its determinant is nothing. Determinant is nothing but what now here? Simply remove the matrix symbol and here write the determinant symbol. And you know AD minus BC determinant, everyone. We already have seen in the previous classes determinant of ABCD is equal to what is it? My AD minus BC. Yes or no? Cross multiplication we have to do. Remember it, everyone? Right? So if I apply that answer, you this is minus 1 you are getting. If you apply minus 1, is it equal to 0? It is not equal to 0. Therefore, what you can say? Therefore, A is therefore for A is non singular matrix. If determinant of A is not equal to 0, if determinant of A is not equal to 0, A is non-singular. And if you see here, A is equal to what is there? And this is a 2, 5 it is there, 2, 3, like a 2, 3 it is there, and this is the 6 and 1 it is there, 6 and 1, 6, 1 it is there. So this is a matrix. What is it? It's a determinant. Determinant of A will become what is it here? This is 2, 1, 6, 3 it is there, 2, 1, 6, 3 it is there,
Correct,
2,
Archie, sir.
1, 6, 3. And what is its determinant value? 6 minus 6 value, this is equal
Sir,
to
your
0.
screen is
Yes, no?
against.
Sir, screen is.
Yes, sir.
Sir, your screen is not visible, sir.
Okay.
Sir,
Chit,
sir, end this meeting and create new meeting, sir.
it's so. No, no. I think yesterday there was no issue, no?
No, sir. Today only a little bit problem is happening.
Now, is it all right, Mano?
Yes, sir.
Okay, it will be all right. Okay, fine. So see here. So do you understand for this particular matrix, determinant value has become how much? 6 minus 6, it will become 0. So this particular matrix, we call it as what is it now? Singular matrix. We call it as singular matrix. We call it as singular matrix, right? So see here, next term. So this is what I have written. When we can cancel A on both sides, if A is non-singular, if A is singular, we cannot cancel A on both sides. Okay, that we have. And most of the time we won't use it. You need not worry about it. And next, what is it more different? Questions here. Question, solve this one. This is let A is equal to what is there here? Let A is equal to
We can't see, sir.
2, 3, 4, 5. 2, 3, 4, 5. Don't worry, don't worry. Just a minute. It will be all right. Just it takes 2 minutes. It will be all right. It takes 2 minutes. It will be all right, man. Don't worry. Yeah, it will be all right now. No? Okay. Are you able to see everyone?
Yes, sir.
Yeah,
Yes,
there
sir.
won't be any issue. There won't be any issue right now. So see here. This is that A is equal to what is it now? This and B is equal to what it is there. B is equal to 1 0 1 2 0 minus 3 it is there. 1 2 0 minus 3 it is there. And find the following things. Find the following things. What is it now? Here first one. Here A into B. Second one B into A. Third one. Third one. This is the A into I, A into I. Fourth one, what is it now? B into I, B into I. And fifth one, what it is? This is A square. And sixth one, what is there? This is B square. So right, B square. And seventh one, this is A square minus B square. A square minus B, A square plus B square. Eighth one, what it is? This is A plus B whole square. and a square minus b square, and what it will be more? This is a plus b plus 3i, right? And ninth, this is 2a minus 3b, 2a minus 3ab, 2a minus 3ab plus 2i, right? And the 10th one, this is what is it now? Next, a cube plus b cube, a cube plus b cube. So these and all, you can find it or not, everyone? Yes or no? Can you find out a into b? Do I need to explain this? B into a also, a into I also, yes or no? What is I here? Identity matrix of order 2 by 2, yes or no?
Yes, sir.
Identity matrix of order 2 by 2, and this BA also you can find it out, not an issue. And a square means what is it more? A square means what you have to do? A square is nothing but what is it more? This is a into a. The same matrix you have to multiply 2 times, 2 3 4 5, and what is it more? This is 2 3 4 5 only, 2 3 4 5 only. Do you understand? So what is it here? You can multiply these, what you are getting? 2 3 2 4 means what? 2 2s are 4 and 3 4s are 12, 4 plus 12 it is, and this will be what? 2 3s are 6, and this is 3 5s are 15. And next, what is it here? 4 2s are 8, 5 4s are 20, right? Next, for second row and second column, 4 3s are 12, 5 5s are 25, 5 5s are 25. So what you are getting here? This is what is it now? 16 and 21, and this is 28, and this will be 37. Okay, so this is about a square. In the same way, if I ask like 11 a power 8, if I ask that also, you can do it or not? Yes or no? Do you understand, my everyone? Do a power 8 means this is a power 8 you need. A power 8 you need means what you can do here? A power 8 means so you know a power 4 is equal to what? Already you know a square here you found, a square into a square, right? And in the same way, and a power what you need actually? 8 means what you can do? A power 8 means a power 4 into a power 4. You need not do 8 times multiplication. You need not do 8 times multiplication. And to find out a power 4, you can multiply a square and a square. From this, a power 4 will come. After getting a power 4, to find out a power 8, you can multiply like this. And then to get a power, that's it. A power 8 is over. Do you understand, my everyone?
Yes,
sir.
sir.
Right. So in the same way, do I need to explain this? No. This is done. This one also you can do. This one also you can do. You can do this one or not? Yes or no? A plus b plus 3i, and even these and all. So these are the questions just for practice. Just for practice. You can do all these or not?
Yes, sir.
Right?
Yes, sir.
Okay. So let us move on. Next, note what is it here? And Shravan Surya, before leaving the class, once stay back. I'll speak to you once. Okay. Is it audible? Are you there, beta? Shravan Surya. Right. So let us see next. What is it? A into b plus a. A into b plus a means you can write it as what is it? This is ab plus ab. A into b plus c. A into b plus c means what you can write here? This is ab plus ac. You can write. It's not an issue. And next, what is it? Here a into b into c. A into b into c means what is the meaning of this? First, you are multiplying b and c, and with the resultant answer, you can multiply with a. Not only that, here a into b, like this also you can do. It's not an issue, right? Next, what is it? This is a into I is equal to what is it? I into a is equal to, both will generate answer a only. And next, what you can say here? A into 0 is equal to what is it? 0 only. Next, what is it here? Next, here you can see. Fine. So these are the things, and if AB is equal to, if AB is equal to BA, then what we say? Then we say Then we say what is it here? Then we say A and B are which kind of matrices? Then we say A and B, these are commutative matrices. These are commutative matrices. These are commutative matrices. These are commutative matrices. Okay. A and B are commutative. A and B are commutative when if AB is equal to BA. If AB is equal to BA. And few more things also you have to note down here. Suppose if you take A plus B whole square means general formula is what, better? Can you tell me? What is the general formula for A plus B whole square? This is A square plus B square plus 2AB, right? Yes or no?
Yes, sir.
Right, but here it won't work, sir. Here it won't work. So you have to write it as what is it? This is A square plus B square plus what is it? AB plus BA you have to write. Because if both are equal, then you can write it as what is it? 2AB. But sometimes always both are not equal, right? Sometimes they equal, sometimes they may not equal. Are you getting everyone? Yes or no? Even this also, A plus B whole cube means what you can write here. This is A cube plus B cube you can write, and this will be what is it now? This is 3A square B. 3A square B, or else instead of 3A square B, what you can write here? We can write it as what is it now? This is A plus B. What is it? This is A plus B. This is A plus B into what it is it now? This is A plus B whole square. You can write A plus B whole square means again you know what you are getting. If you write it as this is A plus B into A plus B whole square, you have written above. What is it now? This is A square plus B square plus what is it now? AB, mute your mics, my everyone. Mute your mics. So it is this. And what you are getting, if you multiply this A inside, this is A cube and this will be AB square. And next, what is it now? This is A square B. A square B. Next, what is it here? Here, A, B, A. Right? ABA you can write. Next, what is it now? Plus B, if you multiply inside, what you can write? This is BA square plus B cube, and this will be B, A, B, right? And here, next to B square A will come. B square A will come. Now you observe here, sir, A, B, A, it is there. No, can't we write it as A square B? Is it correct now? Can we write like this? Can we write like this? A, B, A, can we write it as A square B? Yes or no? Anyone?
Yes.
Can we write like that?
Yes, sir.
No. Reason is no. Reason is no. Reason because we cannot write if you are able to write A B A as what is it no? A B. That means this B A is reversed here. Then you can write it as A square B because A into A is A square. But you observe B A cannot be equal to always A B, right? That we don't know. B A cannot be equal to A B. So we cannot write like this. So what you have to do? You should not write in this way. You should not write in this way. What is it? You have to leave it as it is. You have to leave it as it is. Right? So as like this only you have to do. You should not do any other simplifications. Like direct formula A plus B whole cube formula. You should not apply. Can anyone of you tell me A plus B whole cube formula? Aman, what is A plus B whole cube formula, beta? A plus B whole cube. Negras. Ashmit.
Yes, sir.
A plus B whole cube formula.
A plus B whole cube is equals to A cube plus 3A square B plus 3AB square plus B cube.
Okay. What about remaining? Remaining are not able to tell. Megraj is not responding. Aman is not responding for A plus B whole cube formula. Okay. So what is it now? In this way you have to do matrix. You should not apply identity. When we can apply identity here, we can apply identity. What is it now? If AB is equal to A and B are commutative. If A and B are commutative means what is it now? If A and B are commutative, what can we take? A and B are commutative. We can take AB is equal to BJ. In that case only we can write A plus B whole square is equal to what is it now? This is A square plus B square plus 2AB you can take in this case plus 2AB. And next what is it now? This is A minus B whole square. This will be what is it? This is A square plus B square minus 2AB. The same identities apply as it is in the algebra, right? So this is A plus B whole cube, right? So you can write it as A cube plus B cube. This is what is it now? This is 3AB into A plus B. This you can apply, not an issue. Do you get it, everyone? Yes or no? Any issue with this?
No, sir.
Right. So see here. Here also you can add a few more things. And 12th one, what is it now? This is A into B plus I. A into B plus I. And 13th one, what is it now? This is A square into, this is 2B minus 3AI. So this also you try to find out, everyone. Okay, this also you try to find out. Can we multiply this A inside according to this first property? Yes or no? You can multiply, it's not an issue. Distributive law is applicable, right? So next, what is it now? Here, question. What it is there? Let A is equal to, what is it now? Let A is equal to, this is
Sir, once can you show 12th and 13th question?
what now?
12th and 13th one, sir.
13th one? 13th one, any
Yes,
issue with 13th one? You are noting
no,
it
sir, I
down.
want to. Yes, sir.
Okay. So see here. Next, what is it now? This is A is equal to 1101. It is there. A is equal to 1101. It is there, right? Then A power 2008 is equal to what? A power 2008 is equal to what is it now? This is P, and what is it here? This is Q, and this is R, and this is S, right? So what is it now? Then what I am asking you to find out, then this is 1004. This is P plus S, right? Minus 2008 Q minus simply Q is equal to how much? Is equal to how much? So this is the question. In the same way, second one also, A is equal to what is it now? This is 111. This is 0. It is there. Then what is it now here? It will be A power 2013. A power 2013. This is equal to what is it now? This is equal to what? A power 2013 is equal to what is it now? This is PQ RS. It is there. PQ RS. It is there. PQ RS. It is there. What is it now? PQ RS. It is there. Then what is it now? Then Q is equal to what? Then Q is equal to, like, automatically you'll be able to find out Q here. Then determinant of A power 2013 is equal to what? Determinant of A power 2013 is equal to what? Right. Next, what is it now? Third one. Okay, try these questions once. In this first one, if you observe, A power 2008, I am asking here. These are pattern based questions. Pattern based question means, can we multiply this up to 2008 times? This one. So it takes a very long, right? So if you observe here, this is A is equal to what it is there, but A is equal to 1101. It is there. 1101. It is there. Now you can see 1101. What is A square, beta? Can you tell me what is A square here? A square means what? A into A, 1101, and this is 1101. What you are getting? Can you tell me, any one of you? A square is equal to, do it, everyone. What is A square is equal to?
So 1. So 1. 1.
1.
110.
1
Sir, 1 2 1 1.
1 2 0 1 or not? Yes or no?
Yes, sir.
Isn't it? 1 2 0 1. Now I need what is it, my a cube. Can you tell me what is a cube here? A cube is nothing but what, beta? A square into a. What is a square? A square, you know, 1 2 0 1 you are having. What is a here? A is equal to what, 1 1 0 1. Now if you multiply this again, if you observe, this is 1 3 0 1 you will be getting 1 3 0 1. And if you observe a power 4 also in the same way, a cube into a, if you do, what you are getting, again you will be getting 1 4 0 1. So you have to observe whenever powers are very higher, then you have to observe there will be some pattern in the repeated multiplication of the matrix, right? So if you do the repeated multiplication here, what you are getting in the repeated multiplication, you are observing one thing in the powers. What is that? Here a square is the power is 2, and this only element is increased by 2, and the power is 3, this only element is 3, and remaining elements are not changing. So directly you need not do all the multiplications. Directly by observing that pattern, can you say this is a power 2008? This a power 2008, it is equal to what is it, no? This is 1 2008, and this will be 0 1 or not? Yes or no?
Yes, sir.
Do you understand? So this is directly is equal to what is it, no? This is p q or s. When the powers are high, there will be some pattern in the repeated multiplication of the given matrix. Remember that. Okay. So what is it, no? This implies what he is asking, 1004 into p plus q, right, minus 2, it is q he has asked for, right, into q, right? So what is this one? What is this q value here? What is it? This is equal to, what is it equal to, no?
P plus S minus Q.
P plus s, right? This is p plus s minus q. So what is it equal to, 0 or not?
Yes, sir.
Right? So this is it. In the same way, second one also, can you do better, everyone? Second one directly, can you tell me? Second one I am telling directly. This is a is equal to what it is there. This is 1 0 1 1. It is there. What is a square, beta? A square is equal to what? This is 1 0 2 1. It is there. And this is a cube will be what is it here? A cube also you can observe. This is 1 0 3 1. It is there. And this implies, and so on up to where, this implies a power 2013. A power 2013. What it will be, beta? This is 1 0. What is it, no? Yes. A power 2013, what is it?
102013.
2013, and it is this one, it is there. Therefore, you can see what is asking. Therefore, determinant of a power 2013 means what is it? Determinant of which matrix? The last matrix 1 0 2013, and this is 1, it is there. And if you apply the determinant formula here, 1 minus answer is 1.
Yes, sir.
Do you understand? Right? And one more thing also you can do here. What is it, ma? Determinant of a whole power, determinant of a power n is equal to determinant of a whole power n also. Using this determinant of a power 2013, using this properties we will see in the next chapter, determinant chapter. Okay, with this property directly what you can write, this is determinant of a whole power 2013. What is determinant of a, beta? What is determinant of a? This is 1 0 1 1. This is whole power 2013. It is there. What is the value it is giving?
1.
1. So simply it is generating 1 as the answer. So 1 power 2013 will be what is it? 1 power 2013 will be what is it? 1 only. This is 1 power 2013. This is equal to 1 only. Like this also you can do it. You need not find out the last matrix. Do you get it, everyone?
Yes.
Okay. So this one next. Right. So let us see next one. Note here. No? Note here. What is it here? What is the transpose of a matrix? Transpose of a matrix. Transpose of matrix A. Transpose of matrix A. Transpose of matrix A. How we will represent here? We'll represent this with what is it? No, we'll represent this with A power T. Means A transport, we'll read it as A transpose. Okay, what is it? No, let A is equal to what is it here? Let A is equal to what is it? No, this is here Aij of order m by n, it is there, of order m by n, it is there. Then A transpose will be what is it? No, A transpose will be, this is A J I n by m. What you understood from these notations? Can you tell me? So this is the element of ith row and jth column, and here this is the element of what? Jth column and ith row. The columns and rows are got interchanged. Are you getting everyone? Column variable came into the place of rows variable, and rows variable went into the place of column variable. Do you understand here? Yes or no?
Yes, sir.
So simply we can write in another way also. A transpose is equal to what is it? A transpose is equal to A transpose is equal to, it is a matrix obtained. What is it? A matrix obtained. Matrix obtained by what is it? It is a matrix obtained by interchanging rows into columns. Obtained by interchanging what is it? Interchanging rows into columns. Interchanging rows and columns of A into columns and rows respectively. That means rows converted into columns converted into rows, right? So you see here, for example, to understand this properly, A is equal to what do you have, beta? This is a 2, 3, 5 and 7, 0, minus 1, it is there. So this is A. What is A transpose? What is the first row, beta? First row is what? What is the order here? 2 by 3. What is the first row here? 2, 3, 5. Yes or no? So this will become first column. 2, 3, 5 here. What is the second row? 7, 0, minus 1. It will become second column here. 7, 0, minus 1. Do you understand, everyone? What is the order of this? This is 3 by 2. So you observe here. This is I have written m by n. Here I have written n by m. So rows and column numbers are changed here. Do you get it, everyone?
Yes, sir.
Yes, sir. No. In the same way, B is equal to this one. It is there. B is equal to 2, 0, 5, 1, 2. It is there. So this is a matrix of elements 5. So what is B transpose? Can you tell me what is B transpose, beta? Since only one row it is there, we'll convert it into one column. Do you understand?
Yes, sir.
Right. So in the same way, C is equal to what it is there. No, this is the here. Let us say 1, 2, 3, and this is 0, 1, minus 1, and it is 2, 5, 7. So what is C transpose? Can you tell me what is C
2,
transpose
3,
here?
1.
1, 2, 3. 1, 2, 3. Right? Then 0, 1, minus 1. And third column third row we are writing it as what? Third column. 2, 5, 7. Do you understand, everyone? Yes or no?
Yes, sir.
Now, here you are having A transpose. No, here you are having A transpose. Can you tell me transpose of A transpose? We call it as what? Transpose of A transpose. Can you tell me what is it here? Transpose of A transpose?
2, 3, 5, 7, 0, minus 1.
Yes.
Sir, A.
So here, this one it is, this is the A transpose. For this you have to apply what is it? No? Transpose again. And here, what is the row here? First row is what, better? 2, 7. That you have to convert it as first column. Second row is what? 3, 0. Convert it as second column. And third row is what? 5, 1. So convert it as third column. So again, what you are getting, beta? Can you tell me?
A.
Sir,
A
A.
only, no? So like this, and we can note a few properties, no? We can note few properties of transpose. What is it here? This is first thing. Transpose of A transpose. Transpose of A transpose is equal to what? A. In the same way, what is it? Here you can see A plus B whole transpose. A plus B whole transpose is equal to what is it? A transpose plus B transpose. Right? Next, A minus B whole transpose also you can take it as A transpose minus B transpose. A transpose minus B transpose. And next, what is it here? This is K into A whole transpose, where K is what is it? No? Constant, right? So it is a K, you can take it outside, and this is A transpose, where K is what here, where K belongs to what is it? No? Complex number. This symbol stands for what? Complex numbers. Okay. So next, what is it? No? Complex number means what is it? No? It can be real number also, because all real numbers are subsets of complex numbers. Have you seen that? Have we seen that or not? Yes or no?
Yes,
Have you
sir.
seen that? Right. So it is AB whole transpose. This one you need to remember better properly. AB whole transpose is equal to what is it here? This is a B transpose into A transpose. We call it as reversal law. Reversal law. Reversal law. That means order of A and B is changed. You cannot apply transpose onto A and B directly. You have to reverse the order and apply the transpose. And you can see in the same way, this is A, B, C whole transpose. It is there. A, B, C whole transpose means you can write it as C transpose, B transpose, A transpose. In the same way, if you have A, B, C, D, A, B, C, D whole transpose, it is there. Then what you can write it as? This is D transpose, C transpose, B transpose, and then A transpose we can write. Is this clear? Right. So remember this as a reversal law. And next, what is it, beta? Next, here. Right. And one more thing. This is observe here. A square whole transpose means what is it? A square whole transpose means what is it here? Can we write it as A into A whole transpose? Yes or no? Can we write it as further? If you interchange the order also, according to this property, you have to interchange order of A and A, but both are same only, no? Here A and B are different,
Yes.
but here both are same only. Therefore, what you can say, this is A transpose into A transpose only you can write. And can you write it as A transpose whole square, beta? A transpose whole square? Yes or no?
Yes,
Do you understand?
sir.
So from this, A square transpose is equal to what? No? Square of A transpose, right? So therefore, what can we say? This is A power n whole transpose is equal to what is it, beta? This is A transpose of whole power n. Remember this property. Remember this property, right? In the same way, remember one more property also. Determinant of A is always equal to determinant of A transpose. Determinant of A transpose. Okay, this property we will see in the determinant chapter. Okay, and next, what is it? All right. So these are the things. And next, and can you tell me what is I transpose, beta? I transpose is equal to what? I only, no? Yes or no? I is nothing but what? 1001. What is its transpose if you change the rows and columns? Transpose of this will be what?
1001.
The same thing.
Right? So same thing only will come. So you can see here next. You can see what is the example. What is it? My example A is equal to what it is that A is equal to, this is 2 3 1 0 minus 1 2, and this is a minus 2 0 5 it is there, minus 2 0 5 it is there. So in this case, and B is equal to what it is there? No, it is 1 0 minus 1 3 4 5, and it is 2 0 minus 1. So whole transpose, right? So this one. Next, all right. So these are given. Find what is it? No, find first one. And first one, and C also, let us say C is equal to what is it? No, C is equal to 2 3 5, and this is minus 1 0 0, and it is minus 2 minus 3 1. So like this it is there. So what is it now? Find A plus B. First one A plus B, second one A minus B, and third one what is it now? A plus B, A into B, and fourth one A into C. These and all for practice only, just to go through this everyone. Next, fifth one. Now A plus B, what is A transpose? What is A transpose here? What is A transpose? And what is B transpose? And what is C transpose? Right? So what is it? What is C transpose? And next, what is it? Eighth one. This is A plus B whole transpose. A plus B whole transpose. It is there. And next, ninth one. This is A minus B whole transpose. A minus B whole transpose. Right? So it is just a minute. No. So it is what is it now here? A minus B whole transpose and 10th one. What is it now? This is 2A plus 3B whole transpose. Whole transpose it is there. Next 11th one, A into A transpose, right? And 12th one, A into B into C, A into B into C, and 13th one, what is it now? A into B transpose into what is it now? C transpose, C transpose. And next let us see what is it now? 14th one, what is it? A B C whole transpose, A B C whole transpose is equal to what? Next 15th one, what is it now? Here A square whole transpose it is there, A square whole transpose. And 16th one, this is B power 10, B power 10 is not required. So this is like what is it now? All right. So B transpose determinant of B transpose, right? Next 17th one, what is it now? This is determinant of A plus B whole transpose, determinant of A plus B whole transpose, right? So this one. And 18th one, what is it now? This is A square minus 2AB plus 3C plus 7I is equal to what? Plus 7I is equal to what? So these are all just algebra based questions only. Can you do all these questions, my everyone? Yes or no?
Yes, sir.
Right? So all these
So in the
questions you
question,
can.
did you give
Yes, ma'am.
so in the question, did you give transpose of B or B?
This is P is equal to transpose of this matrix. Directly I have not given. To get B, what you have to do? Apply the transpose
So
inside. So
yes, okay, sir.
solution you observe here, B is equal to what it is now? B is equal to, this is 1 0 minus 1, and this is 3 4 5 it is there, and this is 2 0 minus 1 it is there, and this is full transpose it is there. Therefore what you can write it as beta? This is 1 0 minus 1 you can write, this is 3 4 5 it is there, and this is 2 0 minus 1 it is there, 2 0 minus 1, right? So 2 0 minus 1, like this it is there. Do you understand, my everyone? This is B. Now
Yes.
you can find out everything, right? Is there anyone who can't find anything? Any question if you need, I will explain. Can you do all these questions, everyone?
Yes, sir.
All remaining students, don't feel
Yes,
hesitate. Any question if you ask, I'll explain now. Meghraj, can you do all the questions, beta?
Yes, sir.
Right? Okay. So it is this. Aman, any questions you need? Vanilla, Masini, any questions you need? Right. So let us continue then. What is it now? Next, what is the trace of a matrix? What is the trace of a matrix? Trace of matrix. Trace of matrix. Trace of square matrix. What is trace of matrix A? Trace of matrix A. Trace of matrix A. Right. So trace of matrix A is nothing but what is it? No. This is a trace of A will represent with TR of A. TR of A means what is it now? Trace of A, this is equal to sum of all diagonal elements. We can write I, J, I and we can write like what is it now? This is I and J, where for all what is it now? Where I equal to J, where I equal to J, where I equal to J. Do you understand now? Or else if you feel difficult here, you can write like this also. What is it? You can write like this also. This is I and I only. Both are same. Means this will represent what? Both are same means. Let A is a matrix of order. What? Let A is a matrix of order. 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 What is it? N by N. N by N means what is it? A will be what? Square matrix only or not? Yes or no?
Yes, sir.
Right. And what is it representing? Can you tell me? I is starting from where to here? I is starting from 1 to N. Then what it is representing? This is A11 plus A22 plus what is it now? A33 and so on up to where beta this is and so on up to this is N it is there. So these are all which kind of elements in the matrix? Can you tell me?
Diagonal element.
Diagonal elements. No, trace of matrix A is nothing but what is it? This is nothing but sum of all diagonal elements. Sum of all diagonal elements. Sum of all diagonal elements. Do you understand my everyone?
Yes,
Yes
sir.
or no? Right. So this is it is there. Next you can see. For example, what is it? For example, diagonal exists only for which kind of matrix? Only for square matrix. Yes or no? That means square matrix means it is of order n by n only. It cannot be any other matrix. It cannot be rectangular matrix. Right. So what is it? Let A is equal to what is it? Let A is equal to 1, 2, 3, 4 it is there, and this is 0, 1, minus 1 it is there, and it is 2, 5, 7 it is there. 2, 5, 7 it is there. Right. So what is it? This implies A square is like what is asking? Trace of A. Trace of A is equal to what is it? Can you tell me? 1 plus 1 plus 7. This is equal to what? 9. You understand? Only diagonal elements we have to add up. Only diagonal elements we have to add up. Is this clear, my everyone? Right. So take
sir.
here. This is a very small concept. Right. So let us say trace of A plus B is always equal to what is it? This is trace of A plus trace of B. Trace of A plus what it is there here. This is a trace of B. It is there. And next, what is it? You can see next. Trace of A minus B. Trace of A minus B is equal to what is it? Trace of A minus B is equal to what is it? This is trace of A minus what is it? This is trace of B. It is there. Trace of B. And next, what is it? This is a trace of K into A, where K is a real number. K is not a matrix. We can write K outside and we can write what is it? Trace of A. Trace of A. And where K belongs to? Where K belongs to what is it? Complex number. Do you understand, everyone? Right. And in the same way, what is it here? Trace of AB. Trace of AB, you have to observe one thing. Trace of AB. In the transpose, what we have written beta AB whole transpose means what we have written, this is B transpose into A transpose. But here, sometimes we may confuse this property with this also. Here you may write trace of B into trace of A, but that is not correct. You have to write it as trace of BA. Both are same. Trace of AB is equal to trace of BA. If both multiplications exist. If both multiplications exist, right? So next, what is it? Next, trace of. Right. So these are some basic properties. And trace of A transpose. Trace of A transpose is equal to what is it? Even if you take transpose for this, does the diagonal element changes beta? What is A transpose here? Can you tell me for this particular example? 1, 2, 3, and this is 0, 1, minus 1, and this is 2, 5, 7. Does the diagonal element changed here?
No, sir.
No, right? That means trace of A transpose will be same as what is it? Trace of A only. Is this clear, my people?
Yes.
Right.
Yes, sir.
So this is it. Next, let us see a few questions. A is equal to what it is? A is equal to, you can see A is equal to, this is 1 2 3 4, like this it is there, 1 2 3 4 5 0, and this will be just a minute. No, here So see here, no, this one, what is it? This is a 2 3 5 7, it is a 2 3 2 3 7, it is there like this. And b is equal to, let us say this is minus 1 0 1, and it is a 2 0 8, and it is a 0 1 2, it is there 0 1 2, it is there. Then find out, find what is it, no, find all these things once. This is first one, trace of a, what is it, no, trace of a plus, what is it, this is second one, this is a trace of b, trace of b. And third one, what is it, trace of a into b. And fourth one, this is, what is it, my trace of a into b transpose, a into b whole transpose, right? Next, fifth one, what is it, no, this is the trace of a transpose, right? And the sixth one, what is it, my trace of a plus b, trace of a plus b. And this will be what, seventh one, trace of a minus b whole transpose, a minus b whole transpose, right? Next, eighth one, trace of a plus a trace of b, trace of b, trace of b, mine, like this it is there, right? So try all these questions once. These are all very basic questions only, we can do everyone. And then one more thing, what is it, no, this is the ninth, trace of a cube, trace of a cube, right? And trace of a cube, find it out once. Next, 10th one, trace of a,
So
trace of
excuse
a
me, sir.
whole cube. Yes, ma'am.
So can we write so trace of AB as trace of A plus into trace of B?
Trace of a b as trace of a into trace of b,
Yes, sir.
no, trace of AB is equal to trace of BA only. You cannot apply so any other formula over AB. Okay, you have to do the multiplication of these two, then you have to apply. Then you have to find the sum of the diagonal elements. Okay, remember this.
Yes, sir.
Okay, the property generally they you will get confused with the property. So many properties will be there. You have to be very clear with every property, all of you, right? Is this clear, my everyone?
Yes.
Right. So do all these questions, basic questions only, and we'll continue tomorrow, right? Tomorrow, and once again, tomorrow offline classes only. Okay, tomorrow it is not finalized. If any online classes are there means I'll message you, but as of now, tomorrow offline classes only. Is this clear, everyone?
Okay, sir.
Yes, sir.
Right. And your UT3A, last time it was postponed, no? And that will be conducted on Monday. Timings are 1 to 4. Is it clear, everyone?
Yes, sir.
Okay,
Yes, sir.
prepare for that. And fine. Any other issue? And just in the starting 10 minutes, there was some problem with network issues, right? Any other issues, no?
So step 3.
Okay.
Step 3 problem discussion. Once you came to offline, tomorrow if it is offline, right, afternoon study hours is ours only. In that time I'll discuss, or else Sunday also toppers session is there, no? So in that I'll discuss. Okay, fine. Right, ma, everyone can leave. And Shravan Surya, stay back, ma. Shravan Surya, stay back.